A closed coil having 100 turn is rotated in a magnetic field B is equals to 4 into 10 to the power minus 4 Tesla about a diameter which is perpendicular to a field. So here N is 100, that is the number of turns. Magnetic field is given to me as 4 into 10 to the power minus 4. The omega, that is the speed with which it is rotating, is given me as 300 revolutions per minute. Now converting it into radians, we have 1 revolution as 2 pi radian and 1 minute as 60 seconds. So we have omega as 10 pi radian per second. The area of the coil is, that is capital A, is given to me as 25 centimeters square or 25 into 10 to the power minus 4 meter square, and the resistance of the coil is 4 ohm. Now we have to calculate the average EMF induced if it turns half from its position. That is, for say if the initial position is like this, and this is my magnetic field, this is my point A, this is my point B. So after turning half rotation, the condition will be this, with A point over here and B point over here. The magnetic field remains inside. So calculating the initial flux, that is given by N into B into area cos of theta. Of course the theta will be 0 over here because the direction of the magnetic field and the current induced will be same. So theta is 0, so we can write phi 1 as NBA. Phi 2 can be written as N into B into A cos of 180 degree, because now the angle between the magnetic field and area is 180 degree, so it will be minus of NBA. So the change in flux, that is d phi, is phi 2 minus phi 1, which comes out to be 2 times of NBA if we assume only magnitude. Now to calculate the time dt that it takes to rotate from first condition to second condition, the angle it turned will be pi radian because 180 degree it turned in that time. So to calculate the time it took to rotate pi radians, we write pi divided by 10 pi, which comes out to be 1 by 10 seconds. This can be more clearly understood by a unitary method that it took 10 pi radian coverage in 1 second. So pi radian coverage will be obviously in pi divided by 10 pi seconds. That is what we write here. So we have the value of dt now. So EMF induced will be d phi by dt. So we had 2 times of N into B into A divided by 1 by 10. Substituting all the values, 2 into N as 100, magnetic field is 4 into 10 to the power minus 4 Tesla, area is 25 into 10 to the power minus 4 divided by 1 by 10. On solving this, we get value of EMF as 2 into 10 to the power minus 3 volts. Now to calculate the current, we have I is equals to E by R, that is the Ohm's law. The EMF is 2 into 10 to the power minus 3 and resistance is 4 ohm. So the answer comes out to be 5 into 10 to the power minus 4 amperes. Next part, calculate the net charge. So Q is given by I dt. We have the current 5 into 10 to the power minus 4, and dt, that is the time, given by 1 by 10 seconds. So the charge flown is given by 5 into 10 to the power minus 5 coulombs. That is the answer.